Hello everyone, welcome to Math World. This video is to discuss paper 3-1 for May-June 2025. Okay, let's get started. So for question number 1 is sketch the graph of modulus 2x minus 3. So first of all, we will let y be 2x minus 3 by ignoring the modulus sign. So since this is a straight line, therefore just need 2 points. Let x be 0, your y will be negative 3, and let y be 0, your 0 is 2x minus 3, hence your x is going to be 3 over 2. Okay, so from here, we can just sketch the two axes, x and y. When x is 0, y is negative 3. So let's say here is negative 3. Now the other one is 3 over 2. Say this is 3. So half of 3 is 3 over 2. Now, we know that we are sketching the modulus graph. That means the graph is always positive. Okay, so that means if I join these 2 points, I will get a straight line, but then this negative part will be using dotted line. Okay, because this is not our actual graph. I mean, this is not our modulus graph. Okay, but it is just a straight line for the graph of 2x minus 3. Okay, since there is a modulus sign here, that means we have to flip the negative part into the positive. Therefore, it becomes positive 3 and do the reflection in the x-axis. So this is your modulus 2x minus 3 graph. Okay, so done for question 1a. Now for B, solve the inequality. So just now we have sketched this modulus graph. Now what I need to do is probably I can just refer back to the graph that we have sketched just now by adding another graph. Okay, so I will let y2 be 3x minus 1. So when x equals to 0, my y is going to be negative 1. And if my y equals to 0, when my y equals to 0, my x is going to be 1 over 3. Okay, so now if I add up these 2 points, 0 minus 1, so let's say here is minus 1, and the other point is 1 over 3 and 0. So 1 over 3 probably is over here. Alright, so from here, if I sketch, since this is the working for the part B, so I will just sketch using this. So now we need to solve the straight line, which means the orange line is less than the modulus graph, which means the line is always less than the orange line is always less than the modulus graph whenever it's less than this intersection point. Okay, because here is lower than the upper part. Now we need to find this intersection points by solving the orange line or orange equation and the reflected line. Okay, because our actual graph is supposed to be this dotted line. So now since we have reflected, that means the equation for the reflected line you have to times a minus. Alright, because initially it was minus, so we make it to positive by multiplying negative. So now I need to solve the two simultaneous equations, which means I need to solve 3x minus 1 equals to negative of 2x minus 3. This is for you to get the intersection point. Right, so now here is going to be negative 2x plus 3. Then the left side remains. And now the x will be grouped to one side. Therefore, 3x plus 2x, it becomes 5x. Then for the other side, it will be positive 3. This minus 1 move to the other side becomes 4. So I will be getting x equals to 4 over 5. Which means I know that this is actually 4 over 5. And we know that to get the orange line less than the modulus graph, all your x must be less than that. Okay, so my solution is going to be x is less than 4 over 5. So done for the part B. Question 2 is given that 2 ln p plus ln p minus 1 minus half ln q plus 1 equals to 3. Find the q in terms of p. Okay, so now I will rewrite the question. Now, to get the q, we need to get the q as a subject first. Right? That means now here, I will move this term to the left side and move the 3 to the to the other side. So I will be getting half ln q plus 1 equals to 2 ln p plus ln of p minus 1 minus 3. And now eliminate the half by multiplying 2 to the whole equation. Then you will be getting ln q plus 1 equals to 4 ln p plus 2 ln p minus 1 minus 6. Okay, then now here I have few lns on 2 lns on the left hand side, on the right side. Probably I can change the 6 into ln as well first. So we know that ln e is 1. Okay, so instead of 6, you can just write 6 ln e. Okay, and then after that, to combine few ln, we have another formula which is ln a plus ln b is ln a times b. At the same time, when it is divide, okay, it will be the subtraction. But you have to take note that for these two formulas, to combine 2 ln into 1 ln, the coefficients must be 1, coefficient for ln. That means now here I need to make all this as the power because we have another formula, a ln b equals to ln b power a. That means now here I will be getting ln p power 4 plus ln p minus 1 squared minus ln e power 6. And now for the first two, because this is addition, so I'm going to use the addition formula becomes multiplication of 1 ln. So it becomes ln 4 power 4, p power 4 times square of p minus 1. And at the same time, when it is minus, it basically is a division. So I will just direct divide by e power 6. Okay, so I will just apply two formulas at the same time and put a bracket for the whole function. So now when you compare the left and right side, now I have 1 ln each. Therefore, we can cancel the ln and get the q now. So the q, I will just move the plus 1 to the right side. So it becomes p power 4 times p minus 1 squared over e power 6, then minus 1. Okay, so this is the solution. Alright, now question number 3. Find the complex number z for which this is a real and the modulus is square root 17. Give your answers in the form of x plus iy, where x and y are real. Okay, so now when the complex number is x plus iy, okay, and the modulus is square root 17, so I will just write this modulus is basically square root of x squared plus y squared, then equals to square root 17, which means when we square both sides, you will be getting x squared plus y squared equals to 17. This is my first equation. And then now I refer to the other form, which is a complex number plus 5i over complex number minus 5. It's mentioned that it is real. Real means the imaginary part is 0. Okay, so what I need to do is just replace the complex number by x plus iy. Then you plus with 5i over x plus iy minus 5. Okay, now since the denominator has I or is a complex number, I need to rationalize it. So before I rationalize it, better express it and in the real parts plus imaginary parts first, and same goes to the numerator. So my real part is x and my imaginary part, by factorizing the I, you will be getting y plus 5. So for the denominator, the real part is x minus 5 and the imaginary part will be positive y. Okay, then I times the conjugate of the denominator. And now here we do expansion. So when you do expansion, x multiplied by both, and then the I of the y plus 5 multiplied by both of the terms. Therefore, you will be getting x bracket x minus 5 minus xyi plus x minus 5 times y plus 5i, and then plus, okay, just for information, this one supposedly I should write minus I squared. Okay, because I times I squared, then y bracket y plus 5 over the denominator. Now we have a formula here. Complex number, let's say complex number is a plus bi. The conjugate is a minus bi. So when you times both together, that is going to be a squared plus b squared. Okay, then now here I will be getting real part square plus imaginary part square. And at the same time, when you simplify, you should notice that the I square here is minus 1. Therefore, end up with plus here because minus 1 times minus. Now, my first and last term will be my real part. Okay, so I will group them together and can just do expansion. So here, probably I just group them first. And I split it into real and imaginary part. Okay, so I will rewrite my denominator. And now my imaginary part. Okay, so here I will factorize the I. So I will write the I at the back and followed by minus xy plus x minus 5, y plus 5 over the denominator. Okay, so then this is what we get after you simplify, but in the question is mentioned that the complex number is real. If real means that the imaginary part is 0. Okay, therefore I will just let this be 0. So minus xy plus x minus 5, y plus 5 over the denominator is 0. Okay, given is real. Right, so the imaginary parts will be 0. Now here, when I solve this question, okay, when I solve this equation now, I will say equation, I will say that my denominator just move up to the right side, it becomes 0, which means I will just let my numerator be 0. Okay, so I will just write minus xy plus x minus 5 times x plus 5 is 0. And then now here, we need to solve for the complex number. That means we need to solve the x and y. So we have found the first equation from the modulus. Now the second equation must be found from this current equation. Okay, which means now I have to do expansion. So then now, just multiply. You will be getting xy plus 5x minus 5y minus 25 equals to 0. Okay, so from here, the first two terms can be cancelled off. Okay, and I will be getting the equation in terms of x and y. So obviously, these three terms, 5x minus 5y and minus 25 are multiples of 5. So I will just divide by 5. Then I will be getting x minus y minus 5 equals to 0. And now here, probably I get the x as a subject. It will be y plus 5. Or you can get the y as a subject, right? And let this be the second equation. So now I'm solving the first and second equation. So I will just substitute directly. Second equation into first equation. Now your first equation is x squared plus y squared is 17. Alright, this is the equation. Therefore, now my x is replaced by y plus 5. Therefore, y plus 5 squared plus y squared equals to 17. And now here we need to do expansion. Y squared plus 10y plus 25 plus y squared equals to 17 because it's quadratic expansion. And now here you'll be getting 2y squared plus 10y plus 8 equals to 0. And now divide the whole equation by 2. So when we divide it by 2, you will be getting y squared plus 5y plus 4 equals to 0. And now this quadratic can be factorized. Okay, so factorize it into y plus 1 and y plus 4. So now either y plus 1 equals to 0 or y plus 4 equals to 0. That means your y either minus 1 or minus 4. So once I have found the y, to find the x, just substitute back into the second equation, which means now here I will write from second equation, my x equals to y plus 5. So when my y equals to minus 1, okay, my x is going to be, so here x equals to, x equals to y plus 5, correct. So x equals to minus 1 plus 5, that is minus 4. Positive 4. Okay, mistake. Minus 1 plus 5 is 4. Then when y equals to minus 4, your x is going to be minus 4 plus 5. That is 1. Okay, found this. That means my complex number, remember, my complex number is x plus yi. So now just replace the values accordingly. So it will be x is 4, y is minus 1. So 4 plus minus 1i, that is 4 minus I. And the other one is 1 minus 4i. Okay, so done for this question number 3. Okay, next question number 4. The parametric equations of a curve, okay, given x and y. Find the equation of the tangent to the curve at this particular point. Give your answer in y equals mx plus c, where m and c are exact. Alright, exact means no decimal. Okay, you can leave it in fractions or any other forms, or probably in terms of e. So when we need to form the equation of the tangents, it is a straight line. Tangent line is a straight line. Then you must understand that the m here, the gradient of tangent, is basically dy over dx. Okay, that is a gradient of tangent. So therefore, I need to find the expression for dy dx. So first of all, x equals to exponential tangent t. So now when we differentiate exponential function, this is going to be rewriting the exponential function and multiply by the differentiation of the power of e. Okay, that means now here I will be getting dx over dt equals to e tangent t. So when you differentiate tangent t, it is going to be secant squared t. Right? So you can leave it in this form. Now your y equals to 3 tangent square t. So I will change this into 3 square of tangent t. Right? So this is your y. And now here when we need to get dy over dt, so when we differentiate, right, so we need to use another formula, that is d over dx fx power n. Then this is going to be n of fx degree n minus 1. Then after that, differentiate fx, that will be f prime x. Right? Which means now here, your fx is tangent t, or I would say ft is tangent t. So what I need to do is I bring down the power. So combine with the 3, it becomes 6. Then rewrite the function and the degree you minus 1. That is the n power, the power of n minus 1 here. And now followed by differentiation of tangent t. So that it will be secant squared t. Right. So this is how we differentiate the y. And now to get dy dx, because the m here, remember just now I said it is dy dx, gradient of tangent. So dy dx is basically dy over dt divided by dx over dt. And then from here, I would say 6 tangent t secant squared t, that is our dy dt, divided by exponential tangent t multiplied with secant squared t. Okay, then from here, the secant squared t can be cancelled off. And you are getting 6 tangent t over exponential tangent t. That is our dy dx. Okay, but then the question asking for straight line equation. That means now we need to find out what is the value Okay, so and now the points is given e and 3. But then you have to remember this e and 3 are x and y. But then now we need to get the tangent t. Okay, so probably you can substitute into the x or into the y to get the tangent t value. So now I will say at e3, that means your x is e. Okay, so now at the same time my x is also e tangent t. So which means x, the e is e tangent t. So when you do comparison, this means it is e degree 1 on the left hand side. So I will say my tangent t is basically 1. Now actually when you look at the dy dx, we don't need the t value. I need tangent t value. Okay, because numerator I have tangent t, denominator also tangent t. That means my tangent t will be replaced by 1 here. Okay, so now I will be getting my dy dx. That is 6 times 1 over e power 1. Then you will be getting 6 over e. So this is our gradient of tangent. Okay, so once you have found this, now I can just substitute into my equation of the tangent. So which means I will write here equation of the tangent with m gradient equals to 6 over e at e3. Okay, so y minus y1 equals to m times x minus x1. So which means now you will be getting y minus the y1 is basically the y coordinates of the point, which is a 3. The m is 6 over e, the x minus e. Okay, and don't forget, our final answer is y equals to mx plus c. Okay, so, and somewhat it must be exact. So that means now here, you multiply. Okay, here you just do multiplication. So I will be getting 6 over e x. Then 6 over e times minus e, that is minus 6. And now your y equals to 6 over e x. This minus 3 move to right side. It becomes minus 6 plus 3. Therefore, you are getting minus 3. So this is your equation of the tangent. Alright, now question number 5. The polynomial, okay, so it is a cubic function, is denoted by px, where p, q, a are constants and the a is not 0. Now when the fx is divided by x plus 2a, the remainder is minus 22a cubed. When fx is divided by 3x minus a, the remainder is minus a cubed. Right, so both also remainders. So first of all, rewrite your fx. Now, since the remainders are given, we are going to use the remainder theorem. Okay, remainder theorem says that if your fx is divided by x minus a, okay, the remainder is going to be fa. Okay, so how to get the fa? You just let this divisor be 0. Then your x will be a. That's why your remainder equals to fa. Okay, so I'm going to use this remainder theorem. Now, look at the question here. fx is divided by x plus 2. X plus 2a. So I will let this be 0. Therefore, your x is going to be negative 2a. So I will say my remainder is this. So which means f of minus 2a equals to minus 22a cubed. Okay, now you just replace. See here, fx, f of minus 2a. That means your x now becomes minus 2a. So replace all the x here, and at the same time, this whole value is negative 22a cubed. Okay, so which means now here I will be getting minus 22a cubed equals to 3 minus 2a cubed plus pa minus 2a squared plus 7a squared multiplied with minus 2a plus qa cubed. So then from here you will be getting negative 24a cubed plus 4pa cubed minus 14a cubed plus qa cubed. Okay, now for the left hand side you can just simplify. Here I have a cube. So when you plus together, that is negative 38, and the other two terms will be combined, which means I will be getting negative 38 a cube. Okay, these two terms cannot be combined because here you have p, here you have q, right? So I will just leave them alone. And I notice that all of these terms with the a cube. So which means I can divide the whole equation by a cube. So divide by a cube. Then I will be getting minus 22 equals to minus 38 plus 4p plus q. So I can get the q as a subject. So which means the rest of the term will be moved to the other side. So minus 22 plus 38, that is going to be 16. Then the plus 4p moved to the other side becomes negative 4p. Okay, this is first equation. So then now use a second divisor, 3x minus a, and the remainder is negative a cubed. So now I will let 3x minus a be 0. Then the x is going to be a over 3. And now I will get f of a over 3 equals to the given remainder. The remainder is negative a cubed. Okay, this is the remainder. Now again, replace this. Okay, substitute into your fx. So I'll get negative a cubed and replace the x by a over 3 now. So 3 times a over 3 cubed plus pa times a over 3 squared plus 7a squared bracket a over 3 plus qa cubed. Okay, then now simplify. So for the right side, the 3 and 1 over 3 cube, that is going to be 1 over 9. Then here is going to be 1 over 9 pa cube plus 7 over 3 a cube plus qa cube. Okay, left side negative a cube. And now here divide whole equation by a cube first. You will be getting minus 1 equals to 1 over 9 plus 1 over 9p plus 7 over 3 plus q. Okay, and since the first equation I found the q expression, so probably from here I also find the q expression. So it will be negative 1 over 9p minus 31 over 9. Right, so you just move all the terms from the right side to the left side except the q. So keep the q there. Right, so now since you are getting both same expressions, both also q, I will just write first equals to second. So which means 16 minus 4p equals to minus 1 over 9 p minus 31 over 9. And now group the p on left side. So move the p to the left side and move the term, the constant, to the right side. That means I will be getting negative 35 over 9p equals to negative 175 over 9. Then my p is 5. Okay, so once we have found the p, then we can find the q. So I will refer to the first equation to avoid the fractions. So then I will just write from first equation, my q is basically 16 minus 4p. So 16 minus 4 times 5. Then that is minus 4. Okay, so done for the solution. Alright, now question number 6. Is given three complex numbers. Z1 is 3e 1 over 4i, z2 is 3 over 2e 1 over 6 pi I, and the omega or w equals to 2e half pi I. So what we need to do now here is the first part, state the values of the multiplications and give the answer in REI data, where r is greater than 0 and the data is between minus pi and pi. Okay, so now from here, w z1, okay, it is 2e half pi I multiply with 3e 1 over 4 pi I. So we have a formula here. Complex number 1 times complex number 2, which is where both are in Euler form. My final answer is R1 times R2 exponential I theta 1 plus theta 2. Okay, so which means now here I will be getting 2 times 3 exponential I bracket half pi plus 1 over 4 pi. Then you will be getting 6e. So half plus 1 over 4 is 3 over 4. Therefore, 3 over 4 pi I. Alright, now WZ2, same method. 2e half pi I multiply with 3 over 2e 1 over 6 pi I. Therefore, I'll get 2 times 3 over 2 exponential, factorize I, half pi plus 1 over 6 pi. Then you will be getting 3e. Half plus 1 over 6 is basically 2 over 3. Okay, done for the first part. Now B, on a sketch of an Argand diagram with origin O, show the points A, B, C, D representing the complex number Z1, Z2 and the two multiplications. So now my first complex number is 3e 1 over 4 pi I. And then my second complex number 3 over 2 e 1 over 6 pi I. Then WZ1 just found 6e 3 over 4 pi I. And WZ2 is going to be 3e 2 over 3 pi I. Okay, this corresponds to points A, points B, point C, and points D. You need to draw these 4 points. Alright, so now let's sketch the Argand diagram. Imaginary axis and the horizontal is the real axis. Okay, so now you should understand that this is the theta because your general form is REI theta. So 1 over 4 pi. Okay, 1 over 4 pi, we know that here is half pi. So 1 over 4 pi is in the middle. And the length here is 3. So you just calculate, you just measure. Let's say this is 3. Okay, so here is 3. And then label the 1 over 4 pi. The next one is the angle is 1 over 6 pi. Alright, so 1 over 6 pi, it must be less than 1 over 4 pi. And then the length now is 3 over 2. That means it's 1.5 unit. So let's say here, this is 1.5 unit. And this is 1 over 6 pi. And then this is 3 over 4 pi. 3 over 4 pi is actually 1 plus half pi plus 1 over 4 pi. Okay, which means it will be 1 over 4 pi from the other side. And then the length is 6 units, the magnitude. So here I only simply sketch. Probably you can just measure. So this is a point C, and here is 1 over 4 pi. And lastly, the point D, the angle is 2 over 3 pi, right? And then 2 over 3 pi is basically, you look at here, 2 over 3 pi is half plus 1 over 6 pi. So here is our 1 over 6 pi, that means plus another 90 degrees. So maybe like this, right? Then the length is 3 units. So that here is 90 degrees. Alright, so here I will be labeling 2 over 3 pi. And this is going to be my point D. So it's done for this Argand diagram. Now state the geometric effects of multiplying Z1 and Z2 by W. Okay, so let's look at the W first. Your W is basically 2e half pi I. Because of multiplying, okay, actually when you look at here, your C, okay, look at here, the C is after you multiply the Z1 by W, okay? So that means here, you see, 3 becomes 6. So the length is double, right? I mean, here, this one you times 2, double. And then the theta, 1 over 4 pi becomes 3 over 4 pi. That means you plus 2 over 4 pi. That is plus half pi. Same goes to the points B. Okay, the points B here, 3 over 2 becomes 3. So when you multiply, that means you times 2. Okay, and 1 over 6 pi becomes 2 over 3 pi. Here you also plus half pi. Okay, so that means for the geometrical effects, basically you can just refer to here. Now, the B corresponds to D. The C corresponds to, the C and A are one pair. This is 90 degrees, right? This is pi over 2. That means now here I will say the geometric effects the first one is, okay, rotation, or I will say enlargement, because of the 2. Okay, you times 2. So enlargement with scale factor 2. Right? So this is because of the R. Okay, so because the R is multiplied by 2. Now the second one is going to be the theta with plus. So when you plus means that you must remember the angle is actually counted in this way. Okay, this is your theta positive. Alright, that means it is rotation. So here I will write rotation of half pi anti-clockwise, because the theta is plus half pi. Okay, so that's the geometric effects of multiplying complex number by another complex number. Okay, now question number 7a. Express this in the form r sine x minus alpha, where the r is positive and the alpha is between 0 and half pi. State the exact value of r and give the alpha correct to 3 decimal places. Okay, so now what we need to do is, when you are given this kind of question, whereby you need to express in r sine, you must get a sine x plus b cos x equals to r sine x plus alpha. And here plus, this is plus. And here negative, this will be negative. Okay, that means now here I need to get just these two terms on the left side. But then here you have sign of summation, cannot. So we have to do expansion. So the expansion is going to be the sine formula, the addition formula, or what we call as compound angle formula. So sine A plus minus B. Then this is going to be sine A cos B plus minus cos A sine B. Okay, so I'm going to use this addition formula to simplify first. So this is going to be 5 times sine x cos pi over 6 plus cos x sine pi over 6 minus 4 cos x. Now, cos pi over 6 is basically square root 3 over 2. Sine pi over 6 is half. And now you do expansion. This 5 multiply. Okay, so the first term you will be getting 5 root 3 over 2 sine x. But then the second term you will be getting 5 times half, that is 5 over 2. 5 over 2 cos x minus 4 cos x. You will be getting minus 3 over 2 cos x. Okay, once you have obtained this, then you can express in the r sine x minus alpha form. So I will write 5 root 3 over 2 sine x minus 3 over 2 cos x is going to be r sine x minus alpha. Okay, because that is the requested form. Then now we will just do comparison. Your A is 5 root 3 over 2 and your B is 3 over 2. Okay, so your R will be square root of A squared plus B squared. So 5 root 3 over 2 squared plus 3 over 2 squared. And you will be getting square root of 21. And then the alpha over here is basically arctangent B over A. So 3 over 2 divided by 5 root 3 over 2. Then this is going to be arctangent 3 over 5 root 3. And you will be getting, okay, we need 3 decimal places. And your angle is in radians. So here is going to be 0.333. Okay, so now I will rewrite because the question asking for express this form in the R sign. Right, so I will copy the question right now. 5 sine x plus pi over 6 minus 4 cos x. Then that is going to be, your R is square root 21. Then after that sine, so just refer to this form, x minus 0.333. Okay, so done for the first part. Okay, now B. Hence means use the previous answer, solve the equation for this data and give your answers correct to 2 decimal places. Okay, so I'll copy from A. 5 sine x plus pi over 6 minus 4 cos x equals to square root 21 sine x minus 0.333. Okay, so now we are compare. So obviously your x equals to 2 data. Okay, that means your x is 2 theta. So which means now here, after I replace it by 2 theta, okay, my right hand side in the part A form, the part A answer will be same as square root 7, provided I replace my x by 2 theta. Which means now here I will write square root 21 sine 2 theta minus 0.333 equals to square root 7. Okay, so the square root 21 move to right side. So sine 2 theta minus 0.333 equals to root 7 over square root 21. That will be 1 over square root 3. 1 over square root 3 is same as square root 3 over 3. Okay, so now we need to calculate and solve this. So remember, your theta is between 0 and pi. So that means I will write down my theta is between 0 and pi. And now I'm solving 2 theta. So 2 theta will be between 0 and 2 pi. And now I need to find out my basic angle. So basic angle is inverse sine root 3 over 3. Then this is going to be, okay, 0.6155. Here I give more decimal places, even though you are requested to give 2 decimal places for final answer, because here we are finding 2 theta. It's not 1 theta. Okay. So now I will draw the quadrant diagram. Now, to label the quadrant diagram, look at this. The sign is positive, so that means it will be in the first and second quadrant. And now the basic angle is 0.6155. Therefore, these two values will be equal value. Okay, and now our angle is counted from the positive side because your data is from 0 to 2 data is from 0 to 2 pi. So we have two angles here. The smaller one just rewrite. That means now I'm solving 2 data minus 0.333 equals to 0.6155, and the other one, the blue line, the blue angle, the bigger one is pi minus z value. Okay, then here you will be getting 0.6155 and 2.5261. And now here to solve this, first of all, move the 0.333 to the right side. So it becomes plus. So you will be getting 0.9485 and 2.8591. And then divide by 2. So my theta, now when you divide by 2, you can just give your answer correct to 2 decimal places. So here it will be 0.47 and the other one is 1.43. Okay, so done for this question. Okay, now we are discussing question number 8. With respect to the origin O, the points A and B have these two position vectors. The line L1 passes through the points A and B. Find a vector equation for the line L1. Okay, so just for information, let's say this is line L1. Here you have A and B, 2 points. The line equation is basically A plus TB. Okay, this B is a direction vector. So we know that it is in the direction of vector AB. Okay, so that means I will I will find my direction vector AB first. But before that, I will express these two as OA and OB. So it is 2i, 0j, 4k, and the OB is 5i, 1j, 6k. So now my vector AB is OB minus OA. That is 516 minus 204. So you will be getting 312. Okay, that is my direction vector. So then I will just write my L1 is basically R. Let's say R1 equals to OA. You can take OA or OB, up to you. then TAB. My direction vector here, the B is actually the AB. So here is going to be 204 plus T 312. So done for the first part. Now L2 is given. Okay, so now L2 has equation. Probably I will just write R2. Okay, so L2 has equation R2 with the point 2, 1, 5 because 2i, 1j, 5k plus mu 1i, 2j, positive 3k. Now, you need to show that L1 and L2 do not intersect. Okay, so to show that they are not intersecting, we will first let R1 equals to R2. Okay, so R1 equals to R2. I will copy my R1, 204 plus T, 312 equals to my R2 will be 215 plus mu 123. Okay, so from here, we will bring in the unknowns. Okay, all these unknowns, just bring in. At the same time, ignore the brackets. So I will get 2 plus 3t, 0 plus 1t, so just t, 4 plus 2t, okay, when you bring in, equals to 2 plus 1 mu, 1 plus 2 mu, 5 plus 3 mu. Okay, then from here, right, I will have to substitute, solve any of the two equations to find two variables, two unknowns, first the t and mu. Then the remaining equation is for checking because we want to show that they are not intersecting. Okay, so now probably from the first one, I will get my mu as a subject because the two can be cancelled off. Okay, so I will be getting mu equals to 3t. This is my first equation. Alright, and then my second equation and my third equation. I just remain the rest. So now I use first two equations to solve for the unknowns. So I substitute first into second equation. Therefore, left side is t, right side 1 plus 2 of the mu is 3t. Just replace. Then you will be getting 1 plus 6t equals to t. So the t group one side, 5t equals to minus 1. Hence my t is negative 1 over 5. So once you have found the t, because just now we used the first two equations, now you have to get the mu from first equation or second equation. Okay, cannot be using the third. Alright, so now I will be using the first to get the mu. So my mu is 3 times negative 1 over 5. That is negative 3 over 5. Okay, so since we have used the first and second equations to solve the t and mu, now left the third equation. So the third equation is for checking. Okay, so we have to calculate the left and right side separately. So the left hand side is 4 plus 2t. Then you will be getting 18 over 5. And then my right hand side, it is 5 plus 3 mu. And then this is going to be 16 over 5. So obviously, left hand side is different from right hand side. So your conclusion is they do not intersect. So L1 and L2 do not intersect. Okay, so for this case, I use first two equations. So if you use the first and third or second and third equations to solve the t and mu, your later on, when you will be getting the different t and mu as my answer because they are not intersecting. Okay, so it's just very common in that case. Alright, so done for this question. Now see, find the acute angle between the directions of L1 and L2. Okay, just for your info, if let's say you are given two lines, L1 and the other line is L2. So L2 has B2, second direction vector, and L1 has direction vector B1. So the angle is bounded by B1 and B2. That means now here I got to write down my B1 and B2 first. So B1 is basically the direction vector of the line L1. So my line L1 is the AB 312. Then my B2 is the direction vector of the line 2. So it is 1, 2, 3. Okay, and I define let theta be the angle between L1 and L2. So it is also the angle between the B1 and B2, right? So according to the scalar products formula, so B1 dot B2 equals to magnitude B1, magnitude B2, cos theta. So now 312 dot 123 equals to modulus 3 square plus 1 square plus 2 square. That is the calculation of modulus. 1 square plus 2 square plus 3 square. That is the modulus B2 and cos theta. Now for the left hand side, actually you are multiplying 3 times 1 plus 1 times 2 plus 2 times 3. Okay, so for the right side, first term you get square root 14. Second term also square root 14. Then cos theta. Now from here, the left hand side is basically 11. Right hand side, square root 14 times square root 14, that is 14 cos theta. Then now I will get cos theta is 11 over 14. And now the question says acute angle. So we know that acute angle is between 0 and 90 degrees. So for the cos, it must be positive. That means our calculation is correct. Then now your theta is basically just add cos 11 over 14. And you will be getting 38.2 degrees. So I leave my answer in terms of degree. So if it is in terms of degrees, it must be 1 decimal place. Alright, so let's move on to question 9. The constant a is such that the integration of 6x ln x dx with respect to x from x equals to 1 to a is 4. So the answer is given. Now a, show that a equals to that form, that expression, which is the exponential form, where expx denotes ex. Okay, so which means to get this expression, we need to solve the integration. Because your a is the limit, the upper limit of the integration. Now, when we need to solve this integration, basically there are two types. I mean, it is multiplication of two types of functions, right? Two different types. Therefore, we need to use integration by parts. So for integration by parts, your u is algebraic, and now your u is 6x. So I will write u equals to 6x dv dx is ln x. Okay, just for your information, integration by parts is basically integrate u dv dx with respect to x. That is uv minus integrate v du over dx with respect to x. And now here given limits. So add on the limits. And this is your integration by parts. Which means now here you need to differentiate the u. Du dx is 6 because here we need du dx. And then the other one is going to be v. Okay, we need to get the v. From dv dx, we need to get the v. So that is by integration. Oh, sorry, my u is ln x. Okay, because your you are not able to differentiate the u. You are not able to integrate the ln x. Alright, so your u is ln x. Alright, it's my mistake. So this is 6x. So when you differentiate ln x is basically this formula. Differentiate ln fx. This is going to be over fx. And differentiate fx, f prime x. Okay, which means now here when you differentiate ln x is over x because your fx is x, and differentiate x, there is 1. So for the v, you got to integrate 6x. So it becomes 6x squared over 2, which is 3x squared. And now substitute into this integration by parts formula, I will be getting uv. Okay, so multiply. That is 3x squared ln x with limits minus integrate v du. So multiply v du. That is 3x squared times 1 over x dx and equals to 4. That will be our integration by parts. And now replace the x by 2. So you will be getting 3a squared ln a minus, when the x is replaced by the lower limit, so this is 3 ln 1. Okay, here, when I simplify, I will be getting 3x. You need to integrate 3x. And now here, the next step is to simplify ln 1. Ln 1, we know that is 0. Then now simplify, you will be getting 3a squared ln a and integrate 3x, that is 3x squared over 2 from 1 to a. Now replace the x by a now. I will be getting 3a squared ln a minus 3a squared over 2 minus 3 over 2 equals to 4. After you replace the x by 1, it is 3 over 2. And now here, refer to the question. You need to get a equals to exponential. Okay, so I don't need the fraction. So I times whole equation by 2. You will get 6a squared ln a minus, be careful with this minus, bring it into the bracket, especially for the second term, it should be positive 3, then equals to 8. Okay, now look at here. Before you get exponential, you must have a ln here. That means a term with the ln a, right? You must get a term with the ln a. Before you get the a is the exponential. So which means I will keep the term with the ln a one side. So 6a squared ln a one side first. That equals to the rest of the terms move to right side. These two terms move to right side. So you will be getting 8 minus 3. 8 minus 3 is 5. So 5 plus 3a squared. Okay, then here we need 5 as the first term, and you have a 1 over 6 here, or before that you have 5 over a squared. So which means I need to move down the 6a squared. So 5 plus 3a squared over 6a squared. Okay, so here it will be 1 over 6 taken out, 5 over a squared plus, okay, the 1 over 6 taken out already. That means you still have this over a squared. So that is 3 plus 3. Okay, let's check. 5a squared, 5 over a squared plus 3, then 1 over 6, and exponential. So to get the exponential, we are actually using this formula. E ln a is a. So to eliminate the ln, we will just take e as the base. So that means now a is exponential of 1 over 6 times 5 over a squared plus 3. So we have shown the expression. Okay, now B, verify by calculation that A lies between 2 and 2.1. Okay, so the A we get it from here. Then I will just show the location of the A by using sign change rule. Okay, so just now my A equals to exponential 1 over 6 5 over A squared plus 3. So now I will get the equation in terms of A, so I will move the whole right side to the left side. That means you will be getting A minus. Okay, then I will let all the terms on the left side be FA. And now replace the A by 2 and 2.1 and calculate the value. Calculate both values. Then this is going to be negative 0.0306. Okay, this is less than 0. And then calculate F 2.1. Then this is going to be 0.108, which is more than 0. Okay, so since F2 less than 0 and F2.1 is greater than 0, there is a sign change. Hence, A lies between 2 and 2.1. Okay, so this is how we verify. Now see, use an iterative formula based on the equation in part A to determine the A correct to 2 decimal places. Give the result of each iteration to 4 decimal places. So the formula in A is actually this. So I will just write A equals to exponential 1 over 6 5 over A squared plus 3. Okay, so now since we need to get the iterative, we need to use the iterative formula. That means we need to add on the subscripts. Okay, so this will be my subscripts. So I will write am plus 1. And now, in previous part, we have shown that the A lies between 2 and 2.1. So you can let your initial A be any values in between 2 and 2.1, or probably you can just take 2, 2.1, or in the middle, which is 2.05. Okay, so I let my A naught be 2 plus 2.1 divided by 2. So I start with middle. Okay, that is 2.05. So now I'm going to use that to get the A1. So my A1 is exponential of 1 over 6 brackets 5 over 2.05 squared plus 3. And now each iteration 4 decimal places, 2.0103. That is the A1. Now when to stop the iteration, it depends on the 2 decimal places, because your final answer 2 decimal places. So if you get the similar or same 2 decimal places after you have rounded up the value, then you have to stop the iteration. Otherwise, you have to just continue. So now I'm going to continue because obviously they are not the same. So it will be 5 over 2.0103 squared plus 3. Then this is going to be 2.0263. And again, 2.02 and the previous one, 2.01, okay? They are different. And even I round up the 2.026, it becomes 2.03. That is also different. So continue for A3. Then this is going to be 2.0197. So again, you compare. This is this is going to be 2.02, but the previous one, if you round up, it becomes 2.03. Okay, so now let's continue for one more calculation. Then this is 2.0224. Okay, so now when you check here, this one when you round up, 2.02. Okay, this part 2.02. Therefore, I will just stop my iteration. My A approximate to be 2.02, which is correct to 2 decimal places. Alright, now next question, number 10a. Find the quotient and remainder when the cubic function is divided by quadratic function. So I'm going to use polynomial division to solve this. So here, x cubed plus 5x squared minus 2x minus 15 divided by x squared minus 3. Okay, so now I need to think of one number or one term to multiply to x squared in order to get x cubed. So that term must be x. So x times x squared, x cubed, x times minus 3, that is minus 3x. Okay, now the first term, x cubed minus x cubed, no more. The second term, 5x squared minus nothing, you get 5x squared. And then minus 2x minus minus 3x, that is plus 1x. And now bring down one term. Okay, to get 5x squared from x squared, that is plus 5. Therefore, I will be getting 5x squared, 5 times minus 3 minus 15. Okay, and again, minus. So, first and last term cancel off. Left the second term, the middle term. So when you bring down the second term, that is actually just x. So here we have to stop the polynomial division because the power of x at this moment here is 1 and it is less than the divisor. Therefore, that is our remainder. So I will just write quotient equals to x plus 5 and remainder equals to x. Okay, so done for 10a. Okay, now B, the variables x and y satisfy the differential equation. Is given that y equals 2 when x equals to 2. Solve the differential equation to find y squared in terms of x. Okay, so now B, the variables. Okay, so we need to solve. It is in terms of, we need to solve y squared in terms of x. Alright, so now what we need to do is, we need to separate the variables. So dy over dx equals to x cubed plus 5x squared minus 2x minus 15 over 6y brackets x squared minus 3. Okay, so now when we split the variables, means that your y should be on the left side because your dy dx is the numerator. So I'm moving up this 6y, so it becomes 6y dy. Then the rest just remains, and I move the dx to the other side. Okay, but actually it is just integrates both sides with respect to x. So it looks like we are splitting the dy and dx. So this is what you get. And integrate both sides. Okay, so now we have done the division just now. Okay, so we have done the division. So the division is basically x plus 5. The quotient plus remainder is x over the divisor just now was x squared minus 3. Okay, we have done the division just now. So what we need to do now here is when you when you integrate the left side, this is 6y squared over 2, and then the right side is going to be x squared over 2 plus 5x plus, okay, when I need to integrate that, I will just write, probably I do 2 steps. It will be integrate x plus 5 dx plus integrate the second term or the third term. So when we need to integrate the rational function, okay, this is fx dx, and the numerator will be f prime x. This is going to be ln fx plus c. Okay, so now when I differentiate x squared minus 3, there's going to be 2x. And to get back 1x in the previous part, I have to times half outside. Therefore, this is going to be 3y squared equals to x squared over 2 plus 5x plus half ln x squared minus 3 plus c. Okay, and when you refer to the question where x is 2, y is 2, that means now we need to replace it to find the c value. So you will be getting 3 times 2 squared equals to 2 squared over 2 plus 5 times 2 plus half ln 2 squared minus 3 plus c. Then you will be getting, this is ln 1, okay, 0. So here is basically 4 minus divided by 2, there is 2. So this is 12 equals to 12 plus c. Hence my c is 0. Okay, then I will be getting 3y squared equals to x squared over 2 plus 5x plus half ln x squared minus 3. The c is 0. But then the question asking for y squared in terms of x. So divide the whole equation by 3. Therefore, you will be getting the y squared. It becomes x squared over 6 plus 5 over 3x plus 1 over 6 ln of x squared minus 3. That's the solution of this question. Okay, now next question, number 11. The diagram shows the curve y equals to cos x times square root sin 2x. For this interval of x, the curve has a maximum point at M. Okay, where x equals to a is given. Find the exact value of a. So now, the a is the x value when the m is maximum. That means dy dx equals to 0, then x equals to a. So which means now I need to differentiate my function. Okay, first of all, I will express this as power half of sine 2x. Okay, now since you are given multiplication of two terms, I'm going to use products rule. So differentiate uv is uv prime plus vu prime. And then now my u is cos x. My v is degree half of sine 2x. So now my du dx, differentiate cos, it will be minus sine x. dv dx, okay, first of all bring down the half, rewrite the function, and the degree you minus 1. So half minus 1 is minus half. And now when you differentiate sine 2x, it will be cos 2x, and differentiate 2x, that is 2. Okay, this will be your differentiation. And now here, we need to simplify the half and the 2. Okay, so the half and 2 can be cancelled off. And then here I will write cos 2x. The minus degree change to over square root. Alright, this is your dv dx. And now here we apply the products rule. dy dx is u dv dx plus v du over dx. That means now here I will get cos x, that is my u. My dv dx is cos 2x over square root sine 2x plus v du dx. So the v is actually square root sine 2x. And then I multiply with minus sine x. Okay, that is my differentiation. And now we need to write at m dy dx equals to 0, x equals to a. Okay, so at m dy over dx equals to 0 because it's a maximum point, then the x equals to a. So now replace 0 is cos a, then cos 2a over square root sine 2a plus, or plus times minus is minus, so I will just write minus sine a, then square root sine 2a. Okay, the question says find the exact value of a. So which means now here probably I will get the same denominator over square root sine 2a first. So I will be getting cos a cos 2a. So when you get the same denominator, is actually this is over 1. So I times over square root sine 2a and the same term for the numerator. So now the denominator, when you combine, it will be square root. Then the numerator, I combine, it will be sine 2a. No more square root. So sine a, sine 2a. And this is 0. And when you are solving this, means that the denominator move up to the other side, it becomes 0. Then now I will just write, basically, I'm solving cos a, cos 2a, minus sine a, sine 2a equals to 0. Okay, and now we have a formula to simplify this. Cos a, cos b, minus sine a, sine b. This is going to be cos a plus b. Okay, so I will just apply this. It means my a is the lowercase a, the b is my 2a now. So which means I will be getting cos a plus 2a equals to 0 on the right side. So this becomes cos 3a equals to 0. So your 3a is arc cos 0. This is why you can get it from calculator. Arc cos 0 is pi over 2. Therefore, your a is pi over 6. So this is your exact a. So when you look at the graph, here is pi over 2. That means it's logic that your a is pi over 6 because it is between 0 and half pi. So done for this question. Now B, the region enclosed by the x-axis, the curve is rotated through 2 pi radians about the x-axis. Find the exact volume of the volume generated. Okay, so now this is the region. You rotate here for 2 pi. So it means that you will be getting this solid. Okay, and now you need to calculate what is the volume. So which means, now since you are rotating the region about the x-axis, therefore our volume formula is pi integrate y squared dx. Okay, and the region now from 0 until half pi. So here 0 until half pi. Then now here just replace the y first. So the y is cos x square root sine 2x. And you need to square it. So here is going to be pi, integrate 0 to half pi. Bring in the square. So we bring in the square here. It will be cos square x. Then the square and square root will be cancelled off. You get sine 2x. Now we are integrating this multiplication. Okay, since you have cos square x and sine 2x, so it's different multiple of x. Therefore, we need to change them into same multiple of x by using sine 2a formula or double angle formula. So I will write sine 2x is 2 sine x cos x. Okay, so now I change. This becomes pi, integrates from 0 to half pi, cos square x. Then this is 2 sine x cos x. And now you simplify. The cos square x and the cos x can be combined, becomes cos cube x. The 2 can be taken out. So I will write 2 pi instead of just pi before the integration sign. So here 2 pi, integrate 0 to half pi. It will be 2 sine x cos cube x dx. Okay, so you have sine x and then you have cos x, and some more. The cos x is with degree 3. That means they are same type of functions. So, but then we cannot simplify them anymore. What to do is we use substitution because of same type of functions. So here I will write u equals to cos x, and I will differentiate left side with respect to u, which is 1 du, and I differentiate right side with respect to cos or to x. Okay, or probably you can just write this is du dx equals to minus sine x. So you have two ways to do it. Otherwise, you will just write here is 1 du, this is cos x dx. Right? So maybe I just write that. So 1 du, right side, negative sine x dx. And now here, you can combine the sine x with the dx. Okay, then this becomes negative du. This will be my du. Oh, this is my sine x dx. And don't forget this 0 and half pi are the x values. So when x 0, my u is cos 0. That is 1. When my x equals to half pi, my u is cos half pi. That is 0. Okay, then now here I will change all into u now. So the limits 0 to half pi becomes 1 to 0. And then, oh sorry, no more 2 inside because this 2 I have taken out. Okay, here I have taken out. So no more 2 inside. Sorry, there's no more 2. Then here the sine x dx will be minus du. Okay, the cos cube x, look at here, your u is cos x. So cos cube x becomes u cube. So that means basically, okay, this minus can be taken out. So minus 2 pi integrates 1 to 0 u cube du. Okay, then you will be getting minus 2 pi integrate u cube is u power 4 over 4 limits 1 to 0. And now here you replace the value. So negative 2 pi. Replace the u by 0 first, so it's 0. Minus, replace the u by 1, that is 1 over 4. So at last, it is 2 pi over 4. Then you will be getting pi over 2. So this is your exact volume. Okay, so we have done this paper. So it has come to the end of the video. Thank you for watching. If you enjoy watching my video, please subscribe to the channel and share this channel with your friends. And also stay tuned for more upcoming videos. Thank you everyone. Bye.